What if I told you the Earth almost lost its atmosphere? And nobody saw it coming. No asteroid, no explosion, just invisible particles streaming silently from the sun. In 1989, something hit our planet that engineers still study with fear. Entire power grids collapsed in seconds. Satellites spun out of control. This was not fiction. This was a geomagnetic storm, and it nearly became an extinction event. Scientists have since found evidence of a storm 1,000 times stronger, in the ancient past. If it happened once, the physics say it can happen again. And here is what nobody talks about. We would have less than 18 hours to react. This is the story of the night the Earth almost went dark. Permanently. Stay with me, because once you understand this, you will never look at the sky the same way. The sun is not a stable star. It breathes. Every 11 years, it enters a cycle of maximum activity, erupting with plasma and radiation. These eruptions are called coronal mass ejections, billions of tons of charged particles launched into space. Most of them miss Earth entirely, but some are aimed directly at us. When they hit, they interact with Earth's magnetic field, our invisible shield. This shield is the only thing standing between life and the lethal radiation of space. But the shield has a weakness. Hit it hard enough, and it warps. When it warps, particles stream down toward the poles, creating auroras. Beautiful to look at. But what creates auroras also induces electricity in long conductors, power lines, pipelines, railroad tracks, telegraph cables. In 1859, the first great storm hit. Operators reported sparks jumping from telegraph machines. Some telegraphs continued working even after operators disconnected the power supply. This was the Carrington Event, the most powerful solar storm in recorded history. Astronomer Richard Carrington was sketching sunspots when he saw a white flash on the sun's surface. He reported it. Nobody believed the sun could affect Earth so directly. He was right. 17 hours later, the full force of the ejection arrived. Auroras were visible as far south as the Caribbean and as far north as the equator. People woke up in the middle of the night thinking it was dawn. The entire global telegraph network and the internet of its time went down. Now imagine that same storm hitting today. With our infrastructure, we have 7 billion people dependent on electronics, satellites, and power grids. The transformer systems that run our power grids take 18 months to manufacture. There are fewer than 2,000 of them in North America. Most are over 40 years old. A Carrington-level event today would destroy hundreds of them simultaneously. Recovery time? Experts estimate 4 to 10 years. Without power grids, modern water treatment systems stop working in days. Hospitals lose life support. Food supply chains collapse. The death toll from a Carrington repeat today is estimated between 1 and 2 billion people. Not from the storm itself, from the collapse of the systems we built to survive. This is the quiet apocalypse, invisible, silent, and entirely preventable. But to understand how close we came, we need to go back to 1989. March 9th, solar observatories around the world detected an enormous sunspot. It was the size of 36 Earths, moving fast. 3 days later, the ejection arrived at Earth with almost no warning. In Quebec, Canada, the entire provincial power grid collapsed in 90 seconds. 6 million people lost power in the middle of a Canadian winter. Temperatures were below -20 degrees Celsius outside. The outage lasted 9 hours. 9 hours at that temperature, without heat, kills people. Across North America, over 200 power anomalies were logged in a single day. GOES-7, a weather satellite, had its onboard memory permanently corrupted. Navigation systems used by aircraft drifted unpredictably for hours. But here's the detail that keeps space weather scientists awake at night. The 1989 storm was only a fraction of the estimated power of the Carrington event. A true Carrington repeat would be approximately 10 times more powerful than 1989. In 2012, we almost found out what that means. A Carrington-class ejection launched from the sun, aimed perfectly at Earth. It missed us by 9 days. 9 days in orbital timing. If Earth had been in that position, we would not be having this conversation. This was confirmed in a peer-reviewed paper. It is not speculation, it is documented fact. And yet, almost nobody knows this happened. Why? Because the institutions responsible for telling us chose silence over panic. That decision, and the science behind whether it was right, is at the heart of this story. But before we get there, we need to understand what actually happens to a human body in a world without electricity. Not from radiation, from the consequences. Modern humans cannot survive long without the infrastructure we have built. We have optimized our civilization for efficiency. and efficiency is fragile. A single coronal mass ejection can pull every thread of that machine at once. The physics of this are not controversial. The vulnerability is known, proven, documented. What is controversial is why, after decades of warnings, almost nothing has been done to protect the grid. We will come back to that. First, let us understand the science of the shield itself. Earth's magnetic field is generated by liquid iron spinning at the planet's core. It has protected life on this planet for billions of years. Without it, the solar wind would strip away our atmosphere, just as it did on Mars. Mars once had oceans and an atmosphere. Then it lost its magnetic field. The process took millions of years there. During a geomagnetic storm, it is compressed into hours. Not enough to strip the atmosphere in one event, but enough to cause catastrophic surface damage, increased UV radiation, damage to ozone, enhanced ionization of the upper atmosphere. For living organisms on the surface, prolonged exposure during a major event means cellular damage. The field also fluctuates. It has reversed polarity multiple times in Earth's history. During a reversal, the field weakens dramatically before snapping back in a new orientation. Scientists believe we may be entering the early stages of the next reversal. The South Atlantic anomaly, a region where the field is unusually weak, is growing. Satellites passing over it regularly malfunction. Engineers built extra shielding into the ISS because of it. This is not a distant theoretical threat. It is measurable, ongoing, and accelerating. Now combine a weakening shield with a powerful solar maximum. The Sun entered its current cycle, solar cycle 25, in 2019. It is now at or near its peak activity, solar maximum. Early projections said it would be weak. It turned out to be one of the strongest in decades. The system that monitors and warns us about solar events is called NOAA Space Weather Prediction Center. They have 3 satellites watching the sun around the clock. One is past its design life. The warning window they can provide for an incoming CME is between 15 and 60 minutes. In that window, power grid operators would need to manually disconnect transformers to prevent damage. Disconnecting the grid deliberately means plunging cities into darkness, a different crisis. You trade a recoverable blackout for an unrecoverable transformer meltdown. In 1989, grid operators did not have this choice. They had no warning at all. The surge traveled through the system faster than any human could react. In the years since, automatic protection systems have been designed and tested, but implementing them globally would cost approximately $100 billion. For context, the damage from a Carrington repeat is estimated at $20 trillion. The return on investment is 200 to 1, and yet the investment has not been made. Why? Because the threat is invisible, because it has not happened in our lifetime. Humans are deeply wired to ignore low-probability, high-consequence events. We have a cognitive blind spot for catastrophes that have never happened to us personally. This is called normalcy bias, and it has contributed to every major civilization collapse in history. The engineers who tried to get funding for grid protection faced this bias in every boardroom. They were not ignored because the science was wrong. They were ignored because the timeline was uncertain. A politician on a 4-year cycle does not invest in a threat that may arrive in 40 years. This is the tragedy at the center of the story, not the storm, the system that ignores it. Let us now look at what actually happens inside the grid during a geomagnetic storm. Normally, electricity flows through the grid as alternating current, 60 cycles per second. During a storm, geomagnetically induced currents are injected, direct current flowing in the wrong direction. Transformers are not designed to handle DC injection. It saturates their cores. Saturation causes overheating. Overheating causes failure. Failure is permanent. These are not light switches that flip back on. These are industrial machines the size of houses. Each one is custom built for its specific location and voltage requirements. There is no off-the-shelf replacement. Each failure requires a new custom order, and there are only a handful of facilities in the world capable of building them. During a Carrington-scale event, hundreds of transformers would fail simultaneously. You cannot ship hundreds of custom machines in under a year. Physics and logistics say no. This is the trap. The system cannot heal itself fast enough to prevent the collapse that follows. In 2008, a report to the US Congress modeled the scenario in detail. It estimated that within 12 months of a major grid collapse, 2/3 of the US population would die. Not from the storm, from starvation, disease, and the absence of medical care. The report was received, discussed, filed. The grid remains largely unprotected today. Some utilities in the US and UK have installed partial protection systems voluntarily. The UK's national grid completed a hazard review and installed some geomagnetic protection. Finland and Sweden hardened critical infrastructure due to proximity to the polar regions. China began a national grid modernization that includes some geomagnetic resilience features, but no nation has fully protected its grid. Not one. The most vulnerable nations are those with the longest transmission lines, including the United States. Longer lines act as antennas. The more conductive the network, the more energy it absorbs. This is a structural feature of sprawling grids, and it cannot be changed without rebuilding everything. There is a simpler solution. Transformers can be fitted with blocking devices for under $50,000 each. 100,000 transformers protected at $50,000 each is $5 billion. The US military spends more than that every 3 months. This is not a technology problem. It is a prioritization problem, and it is one that has been made worse by how the information is communicated to the public. Space weather rarely makes headlines. When it does, it is framed as a natural wonder. The auroras are beautiful. The infrastructure collapse they imply is not. This disconnect between perception and reality is the most dangerous part of the story. Now let us look at what space weather scientists actually do, how they watch, and how they warn. The primary monitoring asset is the DSCOVR satellite, positioned at the L1 Lagrange point. L1 is a gravitational balance point between the Earth and the Sun, about 1.5 million kilometers from Earth. DSCOVR acts as a solar wind sensor, the first to detect an incoming CME. When it detects a significant surge, automated alerts go to power grid operators around the world. But DSCOVR was launched in 2015 and is operating beyond its planned design life. If it fails before a replacement is in orbit, that warning window disappears entirely. The replacement mission, IMAP, has been developed, but delays have pushed timelines. There is a window, potentially years, where our warning system could be blind. This is the scenario that haunts the people who understand it most. Not a failure of science, a failure of continuity between missions. In space weather, a gap in observation is not a bureaucratic inconvenience. It is an existential risk. Let us now place this in historical context, because this is not the first time the sky has turned against us. In 775 AD, a cosmic ray event occurred that was so powerful, traces are preserved in tree rings worldwide. Carbon-14 levels in trees around the planet spiked sharply in a single year. The event was so large, scientists still debate whether it was a solar flare, a magnetar burst, or something else entirely. Whatever it was far more energetic than anything in the modern era. In 993 AD, a second, similarly powerful event is recorded in tree ring data. In 1859, the Carrington Event. In 1989, Quebec. In 2003, the Halloween storms. In 2003, a series of powerful solar flares disrupted aviation systems and damaged multiple satellites. The GEO's 11 satellites X-ray imager was damaged permanently during the 2003 events. A Swedish power grid failure left 50,000 people without electricity for an hour. Airlines rerouted flights away from polar routes to avoid radiation exposure to crew and passengers. The 2003 storms were strong, but they were not Carrington-class. They showed us what a medium-sized punch from the sun looks like. A full Carrington punch, and we would not get up. The historical pattern is clear. These events are not rare, they are periodic. The question is not whether a Carrington-class storm will happen again. The question is whether it will arrive during a window when we are watching, and whether we have protected ourselves. The science community has been shouting this for 30 years. There have been congressional hearings, academic conferences, government white papers. In 2015, US President Obama signed an executive order on space weather preparedness. It directed agencies to develop coordinated response plans. Progress has been uneven. FEMA updated its national response framework to include space weather scenarios, but planning for a crisis and actually preventing it are very different things. The insurance industry is increasingly worried. Lloyd's of London published a risk analysis in 2013. They estimated a Carrington-level event would cause between $0.6 and $2.6 trillion in damage to the US alone. Most of that damage is not directly insurable. It would fall on governments and populations. The financial system, which runs entirely on digital infrastructure, would also freeze. No electronic transactions, no ATMs, no supply chain payments, no payroll. A civilizational reset in the most literal sense of the phrase. Now, here's the part of the story where the narrative shifts from fear to decision. Because this story is not inevitable. That is the most important sentence in this video. Every piece of this catastrophe is avoidable. Every single failure point has a known engineering solution. The cost is measured in billions. The benefit is measured in civilizations, and some of this work is already happening in the right hands. A company called Imprimis developed a GIC blocking system that was deployed on North American grids. The technology works. It has been tested. It has been proven. What it lacks is the mandate to be deployed universally. A global agreement on critical infrastructure protection would change this in years, not decades. Space weather does not respect national borders. The sun does not aim at enemies. This is perhaps the cleanest example of a problem that genuinely requires global cooperation. Geopolitics has made that cooperation difficult, but the physics does not care about geopolitics. The scientific community operates across these boundaries by necessity and by design. NOAA shares data with ESA. ESA shares data with JAXA. The science is collaborative even when the politics is not. In 2015, the first international space weather action teams were established by the UN. In 2019, the International Organization for Standardization published the first space weather standards. These are small steps, but they are real ones. The question is whether these steps will reach the finish line before the next major storm arrives. And that answer depends on something that this video cannot control: public awareness. You are now part of the small percentage of people who understand this risk. That matters. Historically, awareness has preceded action in every major infrastructure safety upgrade. Seatbelts were technically feasible in the 1930s. They were not standard until the 1970s. The delay cost hundreds of thousands of lives. The technology was always there. The pattern repeats in aviation, in fire safety, in nuclear waste storage. The gap between knowing and doing is always paid for by someone. With grid protection, the people who pay for inaction are everyone alive on Earth at the time. There are things individuals can do. Keep a 72-hour emergency supply. Know where your local water source is. Have paper copies of critical documents. These are standard emergency preparedness steps. They are more relevant now than ever. But the most important thing individuals can do is understand the policy conversation. Grid protection legislation has been proposed in the US multiple times since 2010. Each time, it failed to advance through the full legislative process. Lobbying from utility companies who feared regulatory costs played a significant role. The irony is that a successful solar storm would cost utility companies infinitely more. But incentive structures in regulated industries often optimize for short-term cost avoidance. This is not villainy. It is a structural problem in how risk is priced and regulated. The solution is to internalize the cost, to make protection mandatory, not voluntary. Some nations have begun moving in this direction. The UK's critical national infrastructure policy now includes space weather as a Tier 1 risk. Tier 1 means it sits alongside terrorism and pandemic in terms of national priority. This is the correct framing. It took decades to get there. Other nations lag behind. The scientific consensus on this risk has been consistent for 30 years. The political consensus is still forming. The sun does not wait for political consensus. In 2024, the most powerful solar storm in 20 years struck Earth. Auroras were visible across the continental United States, Europe, and Australia. Power grids experienced anomalies. Some agricultural GPS systems failed. The storm peaked at G5, the highest category on the geomagnetic storm scale. It lasted 3 days. We were fortunate. The direction and timing were not optimal for worst-case impact. Scientists issued a quiet but significant note. We were lucky. Lucky is not a resilience strategy. Every near-miss event is both a warning and a data point. Near misses teach engineers where the system failed to be tested, and almost always precede the actual event. Aviation learned this. Nuclear power learned this. Grid operators are learning it slowly. The difference is time pressure. The next event will not send a warning that gives us decades. This is why researchers are now calling for a new global treaty, a space weather convention, similar in structure to nuclear non-proliferation agreements, binding, monitored, and enforceable, requiring all signatories to meet minimum standards for grid hardening and early warning systems. It sounds ambitious, but the precedent exists. The will is being built. The question is whether the political will arrives before the next major storm does. Let us end where we began, with the thin blue line at the edge of our atmosphere. That line is not a wall. It is a whisper of gas held in place by an invisible magnetic force. Without the magnetic field, that whisper is gone within geological time. Without the infrastructure we built on top of that thin line, 8 billion lives depend on it daily. The sun has been burning for 4.5 billion years. It will burn for another 5 billion. In that span, it will send hundreds of Carrington-level events into the solar system. Most will miss us, some will not. The only variable is whether we will be ready. Readiness is a choice. It requires investment, coordination, and the willingness to act on invisible threats. Human civilization has made that choice before, when the threat became real enough. Smallpox was real. Polio was real. The ozone layer was real. Each time, we eventually acted. The difference with space weather is the speed of the event. There is no slow escalation to motivate us. One day, the sky will simply turn green and red without warning, and the grid will either hold or it will not. Whether it holds depends on decisions being made right now, in labs, in offices, in legislatures, and in living rooms where people who understand the risk become people who talk about it. This is how every important policy shift in modern history has started. Not with a single heroic moment, with a slow accumulation of informed people who refuse to be silent. The physicists know, the engineers know, the military planners know, now you know. That is not a trivial thing. Knowledge of a shared risk creates a moral obligation, not to panic, not to spiral, but to hold the information and let it inform what you pay attention to. The next time you see a news story about solar activity, you will understand what is at stake. The next time a legislator talks about infrastructure, you will know what question to ask. The next time someone says the risk is too speculative to act on, you will know the history. That history is the evidence. And the evidence points in one direction. The planet will be hit again. The only open variable is whether we will be ready. The thin blue line at the edge of our world is holding. For now. That is the story of the night the Earth almost lost its atmosphere, and the story of every night since. If this changed how you think about something, that is the point. If you want to go deeper, the sources used in this video are documented below. The work of Daniel Baker, Sten Odenwald, and the NOAA Space Weather Center forms the scientific foundation. Their research is freely available. It is not behind paywalls, it is not classified. The information to understand this risk is accessible to anyone who chooses to look. The gap is not information. The gap is attention. You have just spent 30 minutes of your attention on something that genuinely matters. Thank you for that. Genuinely. Share this with one person who would want to understand, not to alarm, to inform. There is a difference between knowing a risk and being consumed by it. The former makes better citizens, better engineers, better policy decisions. The latter just makes noise. Our goal here is always the former. The world has real, documented, measurable, solvable problems. This channel exists to take those problems seriously, without sensationalism, without agenda. Just the science, the history, and the honest question of what comes next. The next video in this series will cover the infrastructure systems most vulnerable to collapse, including the ones that most emergency planners still underestimate. If you found this valuable, subscribing ensures you see it when it arrives. The algorithm does not reward patience. Your subscription does. Until then, keep looking at the sky. Not with fear, with the understanding that you now carry. It is the same sky your ancestors watched. They did not understand it fully either, but they looked. And looking is where understanding begins. The universe is not hostile to us. It is simply indifferent. Our task is to be intelligent in the face of that indifference. We have done it before. The ozone layer. Nuclear de-escalation. Eradicated diseases. This is not beyond us. It never was.